Hey, this is Randy Kaufman, PE, and this is All Things Engineering. Today I'm going to talk about this guy named Elon Musk. And everybody always claims he is the greatest engineer of our time, but the guy's not even an engineer. Now, I'm an engineer in my state. I've had my license for 20 something years. Now, I'm retired these days. I have some medical issues and stuff. But I love engineering. I loved my job. I loved what I did. And, a lot of times I still miss doing it. Because engineering is all about problem solving, and that's all you do. But now, Elon has a degree in physics and in economics. And there may be some states that still allow you to have a physics degree and you can get your license. Our state doesn't do that anymore. They outlawed it like in, I think, 2008 or something like that. But at that point, you couldn't get a license unless you had just a pure engineering degree, not even an engineering technology degree. You had to have just an engineering degree from an ABET university. Now, he has an ABET university, has a physics degree, and there may be some states that still allow that. But you would also have to work in that state for 4 years up under another engineer. He would have to have sit down and give you a reference, approve you, and all that. This is the same thing like a doctor. You go to medical school for 4 years, and if you can't pass the exams, you're not a doctor. You can go to medical school for 4 years, but if you can't pass the exams, and most of the time they pass, their exams are have a really good pass rate, something like 90 some percent. Ours are nowhere near like that. At one point, when I was taking my first part, which is the FE, Fundamentals Engineering, the pass rate was 30%, and the PE part was 50. And you take it 4 years after you've been out of college, and it's in your field. And so then, if you and I know people that took it like a dozen times before they finally got through. It took them. I know one guy probably it took him probably 12 to 15 years to get his license, and he took it that many times, and he finally passed. But it was uh, those tests are 8 hours long, and the tests are tests from hell. The first part is like everything that you've ever had in college: chemistry, electrical, mechanical. It's got statics, dynamics. It's got everything that you ever had in college if you were a STEM major. And engineering is different than physics. Physics is all about theory, and engineering is not about the theory so much as it is about you're taking the math and you're taking the science, and you have experience in that field. And you know from the experience what works and what doesn't work. And when you sign off and you stamp something, you're taking legal liability for it. So if it's wrong, you can be sued over it and you can lose a lot of money. Now, the thing is, it's like I can remember when at I was at a conference one time. So we got this girl. She's probably about 28 years old. She got a PhD from a university. And she's talking about the Bixby River and how it's eroding out and like the water flow, over the last 100 years. And she's got this graph, and it's a nice steady graph going up. And as a matter of fact, if you probably took that graph and you probably took the global warming, it probably matched pretty close. Because the hotter it gets, of course, more water vapor you're going to get and more rain you're going to get, because this thing sits right below the Gulf of Mexico. So that water from the Gulf warms up and it comes in, it dumps water, and that's the reason the river's there even. So her idea was, I'm going to sit down and I'm going to take this riprap, which is huge amounts of, it's these huge rocks. They're about the biggest front end of a pickup truck, and they're made out of white limestone. And she was going to take this, and she was going to go down that river, 175 miles on both sides now. and the bottom. Now, the bottom of that riverbed is smooth. Now, when you put the riprap in there, it's not going to be smooth anymore. It's going to create turbulence. It's going to have a higher. It's going to have a higher friction coefficient. It's going to slow the water flow down. Now, you've already got flooding around that river in a lot of those towns that are close to it. And of course, she's worried about the erosion. I'm like, look, it's eroding out because there's more water, and so you need a bigger river. And but she wanted to stop the erosion by putting this riprap in. And then she was going to plant all these trees up along the tops of the bank to help keep it from eroding. Well, 175 miles of planting trees, even if you can plant them for like $75 a piece, I mean, you're talking about literally tens of thousands of trees. And then with the riprap and stuff, we calculated up. I mean, it was going to be a minimum of about $5 billion. And for a state that gets like 800-900 million a year to spend on all the road repairs, everything that they do. And so you're fitting to stop repairing roads, building any new roads, or doing anything. I mean, you've got people that work there that you got to pay too. So you're going to stop paying them for the next 6-7 years to do this. And not only that, but the amount of stone this would take would be incredible. And I mean, there's no stone that's down in it's going to have to be barged down there. And the stone, if you look, the stone, good aggregates and good stone are getting harder to come by because of all the buildings we've done. And that's the reason you don't give somebody that's been in an ivory tower and all their life and never actually worked a license as an engineer, because you have to consider the cost restraints. And if you look, SpaceX, it does good at that. I mean, they've got a totally reusable rocket. Like, they're going to start they're going to send one to the moon and orbit around. And, this is supposed to only cost like a few $100,000, if I remember right. And it's not very expensive. NASA is going to do the Artemis, and it's going to be way more expensive. And it's not totally reusable. And that's, we tried to do that with the space shuttle. But the space shuttle, by the time the repairs to the heat shields, actually the external tank wasn't reusable. I mean, it still wound up costing a fortune because it wasn't a total reusable ship. Where SpaceX has done this. Now, the Tesla, they're trying to they're trying to get the price of electrical cars down, and they've done a fairly good job. I mean, if you look at it's like I remember the first time I saw the Model S, and it was about a $90,000 car, had 300 something miles of range, which is a good range. I mean, when you can drive 300 something miles, I mean, let's face facts. At the end, after 300 something miles, that's, even if you're doing 70 miles an hour, that's 5 hours straight driving. And that's a long time being on the road. And, and you're not going to do 70 miles an hour all the time. It's just impossible. I mean, you're going to get backed up traffic and everything else. So, you're talking about probably, 6 hours worth of drive time. At the end of 6 hours, you're going to need to stop. You're going to need to eat, something like that. If you've got a charger station anywhere, the ones they got now, you can charge it back up in about 45 minutes to 80% of the battery. Well, 80% of the battery is another 240 miles. Well, by the time you make that, it's going to be time for you to stop for the night. And hotels now put chargers out front. And, and I looked at that car, and that car was a beautiful car. Full-size sedan, beautiful. BMW didn't have anything on that car. And I mean, and a BMW would cost the same price as that. So I'm like, yeah, you've made it competitive for the high-end part. The thing is, Tesla needs to do now is get a car that's much cheaper, like General Motors is doing. But, they're working on it. And I mean, they've done really well. But, the thing is, Elon Musk is not an engineer. I mean, he's probably has a good knowledge of all this, but having knowledge of it and being an engineer are two different things. I mean, that's the same thing about, like I said, the guy that went to medical school. He's got a good knowledge of this, but he's not a doctor. can't prescribe medicine, he can't do surgery. You don't want him to either, because the guys that go through, they do a residency program, and the residency is 3 to 5 years. So, if you're doing, so you're going to study up under a cardiac doctor or an orthopedic doctor for 3 to 5 years. That's when you become an orthopedic doctor. That's when you become a cardiac doctor. It's not just that you went to college and you studied medicine, because the medicine is a broad field that they study, just like we do for the engineering part. And then you need to specialize up under somebody that has expertise in that. And a lot of this is Hollywood's fault. You go in, you look at, like, the old X-Files, and Scully had a bachelor's degree in physics, and she wrote like a thesis in physics, which you don't do for a bachelor's degree. That's just silly. And then she goes off, she becomes a medical doctor. And then, she would have to pass her exams, which she could have done right away. And then she would have done like an internship. And then, she would have had to done a residency somewhere. Well, by the time you do all that, you're going to be, that's 8 years of your life, plus the 4 years of your undergrad work. So that's 12 years. So you're going to be 30. And she was like in her early 20s, or like the late 20s at the best when that show was on. And they had her being fairly young. But then she joins up the FBI. So, you go from physics to a medical doctor to an FBI agent. Okay. Highly unlikely. I mean, if you went into, if you went into physics and decided this is not my forte, but you went to medical school, yeah, you're probably going to become a medical doctor. You're probably not going to work for the FBI because, once you finish your residency, you're going to make a lot more money as a doctor than you are as an FBI agent. And, after all this training and all this knowledge, you're just not going to go work, as a field agent. And then you've got like things like Stargate, where they had Samantha Carter, and she's a premier physicist. Well, premier physicists are not in the military. They're in a university working physics problems, teaching very few classes, and they're working on physics. And, but then she's helping the medical doctors. She knows everything about everything. And it's just like Neil deGrasse Tyson, he's a smart guy, but his expertise is in astrophysics. And he has a good background knowledge of all this. But, he's really only an expert in astrophysics. And that's what people don't get. You're only an expert in one field. Because it takes about 10 years of your life and a lot of work to get to be an expert. And then maybe you can go out and decide, I want to become an expert in something else, and you spend another 10 years somewhere else doing something else. But, you're talking about, you're going to get to be a pretty old guy by the time you do this. Now, the thing is, it's like I said, he's not an engineer, claiming he's like the greatest engineer of our time. Most really great engineers, they're not in the spotlight. They're not it's not the fame, it's not the fortune. It's, they make good money, they can make millions by owning a company, but mostly, they like solving problems. That's what their forte is, and they're a problem solver. But guys, this is a new channel. I hope you subscribe to the channel. Give it a thumbs up if you like it. Leave me a few comments if you would. I'm going to go over a lot of different things about engineering. I'm going to go over things to do about, that I've learned about from engineering, about things about homes where you can cut down on maintenance for your house, save you some money, save you a lot of labor, things of that nature. But, anyway, I hope y'all enjoyed the channel. And thanks for watching, guys.